Hello, this is Suzanne Russ here to talk to you about the last bit of our correlations chapter, the correlation matrix. So let's begin by considering this situation. Imagine that we've gathered information from a large number of students on the following variables: the hours they spent studying, the exam score, an IQ score, hours spent sleeping, and school quality, just how good the school is in general. So what pairs would you expect to be positively correlated? For example, I might expect that hours studying, as it increases, then exam scores would also increase, and vice versa. I'd expect a positive correlation. I don't know if you see any that you think might be positively correlated, and then consider which pairs might be negatively correlated. As one increases, the other might decrease. So give that some thought. And let's look at a study that used these actual variables. So here we have these same variables in a correlation matrix. You can see the variables that we just named listed here in this first column: hours spent studying, exam score, IQ score, hours spent sleeping, and school rating. You can also see those same variables listed across the top. And this is how a correlation matrix works. When you have a number of variables, you want to show the correlations between each pair of variables. This is the way that it's done. For example, you can see here that exam score and hours spent studying have a correlation of 0.82, a strong correlation. You can see that there's almost no correlation between IQ score and school rating. You can see it's 0.02, a zero correlation. We can see that there's a negative correlation between hours spent sleeping and hours spent studying. Tracking across and down, we can see it's minus 0.22, a weak negative correlation. Now you'll notice that half the grid is empty, and you can think about why that might be. Well, first of all, we might have redundancy. Here in this cell, we have hours spent studying and exam score. But if we put it here also, it would be redundant and it might make the table look pretty busy. So we don't like to have a lot of information cross-listed in that way. This very center column, we're going to take a look at on the next slide. So here we have the same correlation matrix with this very diagonal filled in, and you can see that in each cell we have a perfect correlation of 1, the highest score that we can get for a Pearson R value in a correlation. If you look at it, you can see why that is. That diagonal just shows the relationship between hours spent studying and hours spent studying, or between each person's score with itself. And so if you know the hours spent studying that a certain student reported, then you know the hours spent studying that that student reported. So that's why that's often not filled in, because it's always going to be a 1. And as mentioned, all of these other cells would be redundant and might make it look a little busy when you're trying to navigate the table. And now we simply have this correlation matrix showed one more time, this time with all of the cells full, with the redundant information in the columns that we have here. So here we can see, for example, that we have a relationship of 0.36 between school rating and hours spent studying, and that's redundant information here. That's why typically it's only listed once. This gets a little bit busy for the eye to navigate, so those cells are often left blank. Now consider these variables: happiness, job satisfaction, sleep, pets, number of pets, and exercise. Which ones would you think would be positive? Which might be negative? Let's look at the correlation matrix. Here we have one that looks a little bit different then. Here we have our 5 variables listed down and across. You can see this little abbreviation here because it's hard to have room for all of these words going across. And you can see, looking down, the relationships working in the same way. For example, you can see that the relationship between sleep and happiness is slightly slightly inverse, a weak negative correlation of 0.19, or to round up 0.20. When you see a little asterisk like this, this indicates significance. What you can see is if there's one asterisk, it means that the probability of getting a correlation this strong, just by chance, is less than 5%. If you saw two asterisks, it would be less than 1%, or p less than 0.01. And if you saw three asterisks, that would mean that the probability was less than 0.001, less than a very, very minute chance of getting that. And so this is just another way that correlation works. You can see this one includes this diagonal down the middle. It's not necessary to include that. Now let's look at another set of variables. Here we have the variables neuroticism, extroversion, openness to experience, which is acceptance of new ideas or experiences, agreeableness, how agreeable someone is or how much they value harmonious relations, conscientiousness, the tendency to take responsibility seriously, rumination, the tendency to think persistently about negative content, emotional inhibition, the tendency to withhold emotional expression, and aggression control, the tendency to refrain from behaving aggressively when angry. And all of these are considered to be personality traits, regular, stable, consistent traits that an individual has or exhibits. So now you can again imagine, do you predict any positive relationships? Any negative relationships? Do you think that, for example, as agreeableness goes up, that aggression control would also go up? These are the kinds of things we think about. And let's take a look at a different way of displaying these in a matrix. So what you'll notice here is that here, as always, are our variable names going down this first column. And here going across, we have just numbers. In this case, there were too many variables to list all of these words, and so they numbered the variables here, and in the first row going across, they just put the numbers, and that's just to save space. You can see here that the diagonals going down are each variable correlated with itself, and you can look here and see the different relationships. And so if we wanted to know the relationship between, say, rumination and agreeableness, we would have to look at rumination going across and then trace up to the number 4, which is the agreeableness, and we find that there's almost a 0 correlation there. In this chart, you can again see these asterisks. You'll see the 1 asterisk on these variables. These are significant relationships. The rest of them are non-significant, and you can see indicated here in the notes the probability less than 0.05. That should look really familiar to you. Here we can see the 2 asterisks. This word says consciousness, but the actual variable is conscientiousness. That's a typo in the researchers, on the researcher's end. And you can see that the relationship between conscientiousness and openness is the significant, a moderate positive relationship. And so you can see here that that is probability of getting that high of a significance level, that high of a correlation is less than 1%. And so just another way, sometimes you'll see these numbers going across. Now you know what those are about. One more set here. You can see in our class, we have a list of variables, age, height, Facebook friends, and so forth. These are all the variables that students in our class gathered from people they knew. And I just thought I'd show you, I don't know if you can predict any positive or negative relationships here, but I thought I would just show you what the correlation matrix looks like at one point in time. You can see how this is produced outward. This was done, I believe I did this in SPSS, not in Excel, but we could produce this in Excel, I believe, as well. And so you can see here are the variable names. Here are the variables going across. They're written out for us. You can see the dashes going down the diagonal where the 1s would be. You can see the top part of the grid left blank, just because we don't want to put redundant information up. And now we can see that, for example, age and children is a significant correlation of 0.367 with 2 asterisks less than a 1% chance of getting a correlation this strong between any 2 random variables chosen at chance. You can see an odd correlation between openness to experience and sleep. A negative correlation. The more open a person is, the less sleep they get. Also significant at the 0.01 level in a two-tailed test. And so you could look through here some more and see all kinds of interesting correlations. This is just so that you could see what our data looked like. To end, I want to show you this is something that you might actually see in the journal article. This one is taken from a 2015 article in Frontiers in Psychology. And you can see that this one looks a lot more complex. So I want to just orient it to you for a moment. So first of all, you can see the variables: relational victimization, relational aggression, overt aggression, pro-social behavior, peer rejection, number of friends, and peer attachment. So you can see they're numbered. And if you go way over to the right, you can see these numbers up here. So this is representing over on this side of the chart, a correlation matrix. So let's orient to this a little bit. So first off, we have the variables, and then for girls and for boys, they presented the mean and standard deviation. So this just is, the researchers are just giving you the raw data. But then you can also see here the F-test, which is a statistical test along the t-test type of variable called an analysis of variance. And so you can see here that this 1 asterisk means that the result was significant. 3 asterisks means it was very, very significant, and you can see these referenced right here. So they're telling you that they did a statistical test comparing these variables for boys and girls, and you can see that on some of these boys were higher than girls, and in some cases the opposite, like peer attachment. Now, over here is where we see the correlation matrix, and you'll see that we have this nice diagonal going down with all our 1s. We have the variables here showing the correlation levels, for example, between relational aggression and relational victimization. We have a 0.13 correlation, a weak correlation that's positive. But then you'll notice we have different numbers going across the top. And this is a thing that's sometimes done in research to save space. You can see here in the note that the girls' correlations were presented above the diagonal and boys' correlations were below the diagonal. So all of these correlations in the upper corner related only to girls. All of these in the lower corner relate only to boys. So you can compare them. You can see, for example, that relational aggression for girls had a highly significant relationship of 0.65, and that's with overt aggression. Relational aggression and overt aggression positively correlated at 0.65 for girls. For boys, let's take a look at that same comparison. We have an even stronger correlation for boys at 0.73. So this allows you to compare girls and boys in this correlation matrix. It allows you to see what the significant tests were along with the mean and standard deviation, and also allowing you to just save space. So if you come across something like this, don't be put off. Now you know how to read it. This is in a nutshell. If you just pay attention, take your time, look for things you already know. You know the asterisks now, you know the significance levels, you know mean, standard deviation, you know n. All of this you can now interpret. So don't be put off if you see something like this in a research article. All right, that ends this lecture. Thank you.